Good afternoon and welcome to another episode of BCS Careers Inspiration. This series is designed to introduce you to a range of different people who've chosen a career in technology, hear a little bit about them, their background and their experience, and find out what their job is like. So today I'm joined by Liam, who's a senior engineer at Hive Dynamics. Thanks very much for joining us, Liam.
Hello, thank you.
Thanks. And to start us off, could you just tell us a little bit about Hive Dynamics and a bit about your job there?
Yep. So I'm a senior engineer at Hive Dynamics, and Hive Dynamics is a company developing new sensor technologies and data harvesting techniques for various businesses in various industries. And the basis of our technology is an artificial sensory skin that can detect different environmental variables such as pressure, temperature, and strain. Right now, we're looking to apply this technology to the aerospace industry. And we are working closely with large organizations to be able to apply this special artificial skin to surfaces and detect how the surfaces behave in an aerodynamics environment. And so my role at Hive is primarily to do with the electronics, so that's all its hardware. But due to the nature of the research development, which is pluridisciplinary, I'm also doing some software development and some aspects of material science and chemistry. So it's quite a vast role.
Yeah, definitely. And so you've told us a bit about what the organization as a whole does. Can you give us an example of a project or something that you're currently working on?
Yeah, of course. So let's say for this particular technology to operate, we know that we need a certain amount of electronics, hardware and software for this to work. And so in order to collect a large amount of information from different sensors, we need to organize this artificial sensory skin in a certain way. So I've been part of the development team that's actually patentable technology. So we've developed a patent together. And this is about how to actually collect large amounts of information from this sensor array, but also the ability to actually read different types of environmental data, such as the three different quantities, which are temperature, strain, and pressure. And so the development of this technology involves electronics. So for hardware, that is the actual components inside the system. So how do we actually read this signal that's coming from the environment? That is the translation of changing pressure into a changing signal, and then performing calculations on that and being able to transmit that data, may it be through wires or wirelessly. So this is all this systems engineering and electronics engineering is something that I'm in charge of right now.
Wow, that sounds amazing. And it's quite a sort of specific area of work. Can you tell us how you got into it?
Yeah, so my background is electronics engineering. So I did a bachelor's degree in electrical, electronics, and automatic control. And that taught me the basics about electrical engineering and electronics engineering, how, what exactly is electricity, and the basics of different concepts in electronics, such as hardware for computing, but also what's called instrumentation electronics, which is the actual translation of physical quantities into what's called an analog signal, and then being able to treat that signal numerically. So you cut that signal up into different pieces, and then you translate that onto a number of levels in terms of actually, for example, so it can be read by a computer. So it's a technical degree. It's definitely something you would go into if you've studied maths and science. And so I've gone all the way to a master's degree. And I've now, through different experiences, especially through my specializations at university, where I studied what's called electrical impedance tomography, I've been able to apply this now to a professional environment where these kinds of requirements and this kind of knowledge is very acute and quite very, very adaptable to this kind of industry.
Yeah, that's really interesting. And so What would you say is the most kind of exciting bits of what you do? I guess there's quite a lot of experimentation, and because the work is so new and cutting edge, that must be quite an exciting kind of thing to work with.
Exactly. It is very exciting, and it's especially exciting when you get to contribute to developments in really interesting, um, or, what's the word, industries such as aerospace. So, the idea of participating in, the perfection of an aeroplane, the amount of engineering that goes into this, and the amount of, man hours and effort that goes into this, you feel really sort of responsible, and it's quite, it's you feel really valued when you're able to make something that works and that will actually help people to develop this kind of technology. So um, the most exciting parts, I'd say, is when you're faced with a problem and you find the solution to that problem. But not only that, you know that that problem is something that's going to affect a lot of people. So in essence, you've actually participated in helping a lot of people's lives.
Yeah, definitely. In mind are kind of helping other people in their lives with the technology that you're working on now. When it's complete, like how will it be used in the aerospace world?
So it's used for um, actually calculating directly the amount of forces that are applied to a surface. So as let's say an aeroplane or a car is going through the air at high speeds, we want to be able to calculate the downforce on that vehicle, or let's say the lift on that plane, on the plane wing. And so to do that at the moment, there are complex mathematical models that are used on computers, but these are very costly, and you can't actually get pinpoint accuracy. There are approximations involved, whereas the idea of this sensory skin is to get the real values um, directly from the actual surface of the plane. So you're able to not only test in real environments, but also get better data. And
That's
that is
brilliant.
that's the primary pathway. But there are also many different applications for what's called soft sensors, which is this is what this artificial sensory skin is going to be. And this can be also applied into industries such as healthcare, where we can create patches that are very low profile, but enable doctors to get lots of data, valuable data from a small device.
That's really great. Thanks very much for sharing that. And it'd be great to hear about your typical like working pattern. Do you usually work sort of like Monday to Friday, 9 to 5? Are you based in the office, or yeah, just what your working sort of pattern is like, really?
So my working pattern is actually quite, what's the word? Um, well, I'd say, not intense, but rather very sort of, fast paced. We're developing
Mm.
many things at the same time. And we are a very sort of close knit team where we communicate and collaborate very often, albeit remotely most of the time. So there are obviously, we have colleagues who are working in the laboratory developing the technology, who we are in touch with regularly. Um, and so my role, because it's a primarily design and planning of how this technology is developing, I might go to the lab less often, but there's a lot of work happening, hands-on, practical research and development, and these are colleagues we're in touch with every day. And so yeah, there's many different ways of actually doing engineering. This is one of them. Obviously, I still go to the laboratory and see what's happening sometimes, but at the moment we're able to do a lot of this remotely, which is fantastic as well.
Definitely. And what about outside of work? What kind of things do you like to do in your free time?
Okay, so I am a keen gamer, and I'm also a keen swimmer actually. So if I can sort of balance my week with those elements involved in there, that's definitely something that I'm happy to do. I'm also, I enjoy prototyping electronics and developing some basic applications as well. Is quite good fun. But yeah, I mean, I would say gaming definitely up there. So yeah.
Great, thank you. And the last question really is about any either tips for people who might be interested in working in a similar area to you, or any sort of more general piece of advice that you think, oh, I wish someone would have told me that a few years ago? It would kind of really help me grow or learn something new as a person.
So yeah, back when I was studying for my A levels, or even before then, I was really struggling to know exactly what I wanted to go into, and I didn't really see the applications of much of what we were learning in mathematics and sciences. Um, so if there is one, there's a couple pieces of advice, but the first one that I'd like to give is to definitely find as early as possible the topics that you are interested in. And look into what kind of roles are available with the knowledge that, your strong points, and the topics that interest you. What are those jobs that are available outside, after university, or after whatever level of diploma that you have? Definitely try and identify those, and that will give you the strive to achieve something, and you will feel the value when you actually achieve different objectives down that road to success and your desired career path. But in addition to that, there's also another element which I think is really important, and that is to keep your options open, but in a sense, in a social sense. So that is, um, make sure that you're not only studying hard, but also keeping in touch with people that you are studying with. These close friendships and links will open doors for you later down the line that you may have never thought would happen. So definitely don't, even though you're working hard, don't close yourself any doors by being sort of in complete solitude. Definitely keep those doors open, make friends, and go for what you're enjoying. Go for that objective that you fixed yourself.
That's very good advice, and something that we've heard from a few of the other speakers as well, about kind of making some links and keeping in touch with people along the way, because
Yeah,
later on you never know what might come from that. That's really great advice. Thank you very much, Liam, for joining us today. It's been
it's a
really great to
pleasure.
hear from you. Thanks
Thank
very
you.
much.
Thank you, Olivia.